Great. Thank you so much, Elaine, for that lovely introduction. So thank you all for being here. I'm very excited to be here with you. And today I'm going to give you sort of a conceptual introduction to meta-analysis. And so we'll just go ahead and get started here. My goals today are really to talk about the relationship between systematic review and meta-analysis, provide a few examples of questions that you could address using the methods of meta-analysis, then maybe present and look a little bit more closely at some examples of meta-analytic results, and then talk a little bit about interpretation. And then I hope there will be lots of time for us to have questions afterwards. So let's start with at the beginning, which is where I always start. And that is to talk about the definition of a systematic review. And when I think about systematic reviews, I think about them as using explicit and transparent and replicable processes to identify, assess, and synthesize results of multiple studies. And all of this is to address some central research question, while at the same time trying to minimize bias and error at each step of the process. Okay. And so this definition of systematic review assumes that the goal of our review, what we're trying to do, is be transparent in the way we look at literature on a given topic. And we assume here that the review is focused then on synthesizing a set of studies identified through some replicable process. But note, what I haven't said anything about yet is sort of how we do that. How do we do that synthesis? And there could be multiple ways that studies are synthesized in a systematic review, depending on the research question and then the literature that's relevant to address that question. And so just to make sure we're all on the same page, this is how I think about the terms that we use in this area. I think about systematic review or research synthesis as the big term. This is the umbrella term. These are the set of methods that we use to systematically and transparently gather a bunch of studies on a given topic. But how we analyze that is what's underneath our umbrella. We might use qualitative synthesis methods because we're interested in a question where we need to look at qualitative data. We might be interested in evidence and gap maps, understanding where the studies are that look at a given issue. Or we might be interested in meta-analysis. So meta-analysis is one way we might synthesize results from a set of systematic reviews, as Elaine has pointed out. So today we're going to just talk in very conceptual ways about meta-analysis. And how I think about meta-analysis, or my definition of meta-analysis, is that meta-analysis is a set of statistical methods used to synthesize quantitative results across a set of studies. Okay, and so we're going to focus only on the synthesis of quantitative studies in this talk. And I'm also going to assume that we're conducting a meta-analysis in the context of a systematic review. Okay, so it's always good to remind ourselves that systematic reviews don't always include meta-analyses. For example, we might have a question where we don't have quantitative results. We might be interested in how teachers or students experience a given intervention, for example. And that might not include anything that has to do with numbers. And then we might see some meta-analyses that don't use systematic review techniques, that somehow they used meta-analysis on a set of studies that were gathered in an unsystematic way. So again, today what I'm going to be talking about with you is conducting a meta-analysis as part of a systematic review. And so this, if you know anything about systematic reviews, you'll know these steps. These steps, like all steps of research, we have steps in research that we follow, and for systematic reviews, we follow these particular steps. Start with a problem, systematically, comprehensively, and transparently search the literature, figure out what studies are going to be eligible for our review, we extract information from them, and then it's in that fifth step, that data analysis and synthesis step, that we talk about meta-analysis. Okay. And so just to remind us, or if this is new to you, how do we do, what happens in a meta-analysis? Well, after we've conducted a systematic search of our literature and we screened for eligible studies that address our question, we then from each study extract what we call an effect size, which we can think of as a measure of that study's results. So we'll see a couple examples in a second. So for example, we might be extracting some measure of the difference between the treatment group and the control group in a given, if we're looking at an intervention study. And it's these effect sizes that are then used as our unit of analysis in the meta-analysis part of the systematic review. So what meta-analysis does is use statistical methods to analyze these measures we've extracted from each study. Okay. So let's talk about sort of the range and at least a couple of types of questions that we might address when we use meta-analysis. Okay. So sort of three big buckets or three big areas that we might use meta-analysis to address across a set of studies is, one might be we're interested in rates or trends of something, and we're going to look at a bunch of studies that can tell us something about that. We might be interested in associations. So we might be interested in, say, how, for example, income relates to academic achievement. Or we might be interested in cause and effect. We might be interested, for example, in whether or not an intervention is effective. That is a cause and effect question. We can basically use meta-analysis to analyze the results across a set of studies for any question where we have a quantitative measure. Okay. So let's look at some examples. So here's an example where we might be interested in using meta-analysis to estimate a rate or a trend. This is a paper from the Journal of Autism and Developmental Disorders looking at the prevalence of self-injurious behavior in autism. So here, trying to understand how prevalent this particular behavior is among people with autism. And so a set of studies were gathered that was trying to estimate this prevalence, and we can use meta-analysis to say what is the average prevalence as reported across this set of studies. So a second question that might be of interest to us is one about associations or correlations. And here is an example of a study that I was collaborator on that was just published, I think, at the end of 2021. And this was a study that was interested in associations or correlations. And, the authors were interested in understanding the relationship between spatial skills and mathematics achievement or performance. And so here the interest was, what is the average correlation between between someone's spatial skills and their math achievement? There's been lots of research and interest in understanding this because some researchers think that perhaps we need to help children develop better spatial skills, and that may have some impact on their mathematics performance. And so what we did in this study was look at what is the correlation that is estimated within a bunch of studies on this relationship between spatial skills and mathematics performance. And how much does that correlation vary across a set of studies? And then we might also be thinking about associations in a little bit different way, such as sort of as differences between or among groups. So here's an example of a meta-analysis, systematic review and meta-analysis published in 2016 in the Review of Educational Research that was interested in generational differences in academic achievement among immigrant youths. And so their main question was, what is the difference that is estimated across these studies and academic achievement among first and second generation youth? So children who are whose parents immigrated versus children whose grandparents immigrated and so forth. And how if that difference exists across studies, does it vary across studies? Does it vary for different immigrant groups? Does it vary for different time periods and so forth? And then finally, I think maybe the most common method of common context in which we use meta-analysis is understanding effectiveness of interventions. Okay, so where we're really interested in understanding if some new educational curriculum or some new program is effective, and so we're comparing some treatment group that got the studies that are included, compare some treatment group that got a new intervention and the control group that is using sort of the same or business as usual. So one example here is on the effectiveness of mindfulness-based interventions for primary and secondary school students for improving their cognition, achievement, behavior, and so forth. So here's one example of that type of question we might address in a meta-analysis. And then one more example, because we're going to use both of these two examples to look at some results, is one from a recently published very large systematic review and meta-analysis looking at mathematics interventions from a meta-analysis of 191 randomized experiments. This is looking at mathematics interventions from pre-kindergarten all the way through high school. Okay. And so here the interest, and I'll talk about what they were interested in, but they were interested, we'll talk more specifically about that, but they were really interested in how varied these interventions are. So again, we have sort of these range of questions we might address in a meta-analysis where the studies are all reporting on some quantitative measure that they've gathered in their study. It might be about the effectiveness of an intervention. It might be about the strength of a correlation between two constructs. It might be about how prevalent a particular behavior or condition is. So what are the typical results we might get from a meta-analysis? So in a meta-analysis, we're going to be concerned with sort of two major questions. And these are also questions we might be concerned with whenever we use statistical analysis. So the first is estimating the average effect size. You know, what is the average treatment effectiveness across a set of studies? Are mindfulness interventions effective in improving a child's cognition or metacognition or their academic achievement? Or we might be interested, again, in the average correlation between spatial skills and mathematics performance. Or we might want to understand what is the prevalence of a given condition across these set of studies. So our first question might always be, what's that average effect across a set of studies? What is its confidence interval? How much does, how good of an estimate do we have of that average effect? But we might also be interested in, and sometimes this is the more interesting part of a meta-analysis, how varied that effect size is across studies. We use the word heterogeneity to talk about that variation. But we often want to know not just if on average that new program works, but we might want to also know how varied it is across a set of studies. And are there contexts where that intervention is more effective than in other places? And that's about that second question in a meta-analysis, the variation among studies. Okay, so here's just a small example from the mindfulness review. And this is giving us sort of a graphic of what the average effect is across a set of studies, looking at the cognitive outcomes for children who were involved in a mindfulness intervention. So if this is, let me just orient you to this. If you look on the right-hand side, this is what's called a forest plot. And what we have here are each of the squares represent the average effect size from each study. You might notice that they are different sizes. The sizes are in proportion to the sample size of the study. So bigger boxes are bigger studies. And you'll also see the little whiskers coming out from the box. Those are the confidence intervals around that effect size from that study. And you'll notice that the smaller boxes have longer confidence intervals, indicating that we have less precise estimates of what we think the effect size is for those studies. At the bottom, what we see is a representation of that mean effect size. And remember, just a few minutes ago, I talked about that being, one of our goals. What is the average effect of this intervention across a set of studies? And we see here, this little diamond shows us that it is to the right of 0. And so that this is favoring our mindfulness group, our treatment group. And across these studies, on average, mindfulness interventions are leading to our treatment group, our mindfulness group, having higher cognitive outcomes or outperforming in the cognitive outcomes of our control group. Okay, so this is sort of one thing that meta-analysis can give us, this sense of what the average effect is across a set of studies. But you might also say to me, but wait a minute, some of the studies are on the other side of 0. And we see a little bit of variation here. Not all the studies are universally in favor of mindfulness for increasing cognitive outcomes. And that's getting at that second question of meta-analysis. How varied are our results across studies? Okay. So here's a graphic from the mathematics intervention meta-analysis that I just talked about a few minutes ago, the one that has 191 randomized controlled trials. Here we have each dot here. So remember, there's 191 studies included in this meta-analysis. And in fact, every study contributed multiple effect sizes. So there are actually 1,000 effect sizes across these 191 studies. But what this graphic is showing us, let's start with the top row. For all the interventions that they found, all the studies that looked at curriculum interventions, so that would be sort of new books, just a new set of curriculum in math. This is every dot there is a study. Think about that as an effect size from a study. And so this is showing us a couple of things. You'll see the dotted line in the center here. This is the line of no difference between the treatment group and the control group. So if there's an effect size or a dot on that line, that means that the new curriculum was no different from the old curriculum, okay? Everything to the left of that dotted line means that the old curriculum was better than the new curriculum. Everything to the right of that line means that there was a positive impact of the new curriculum. The students in the new curriculum outperformed the students in the control group. You'll notice that there's a dark shaded line in the middle of the box. That is the mean effect size for that set of studies. And there's a little bit of shading around that. That's the 95% confidence interval around that mean effect size. And then the boxes are what we call the 95% prediction interval. So that's where about 95% of all the effect sizes are, the distribution of the effect sizes are in this set of curriculum effects. So a couple of things I think one thing that you might see right away is how much variation there is in the effects of these mathematics interventions. And we can also see that sometimes just reporting the middle column, that mean effect size, isn't as informative as understanding how varied these interventions are. And so what meta-analysis can do, and why I said that exploring heterogeneity is one of the sort of more interesting things of a meta-analysis, is that what you can do now is try to understand what might be related to those differences. For example, we might say, are all of these really effective interventions over here with big effect sizes, are they all for early childhood? Or are they all about geometry? Or are they all with teachers who are very experienced? So meta-analysis can help us start to ask those questions and explore potential reasons for all this variation in the effects of math interventions. I'm sure we're going to share the slides. So I encourage you to click on this link. This link here goes to the tool that is behind this picture. And what you can do in this link is do that exploration of heterogeneity. You can look to see where the effect sizes are in these different clouds, where the ones are for early childhood, or where the ones are for curricular interventions for geometry, and so forth. And so you can begin to explore for yourself, where those effect sizes happen to fall in that distribution of effect sizes. Okay. So finally, and I want to talk, just a little bit about conclusions that we might draw from a meta-analysis. So as we've seen in our example, meta-analysis results can both provide an estimate of the average effect across studies, such as the average treatment effect or the average correlation between constructs. And we can describe also how much variation there is. And then if we have enough studies, we can begin to explore relationships among study characteristics and effect sizes and try to get at why those results are not agreeing across each study. And that's an important part of a meta-analysis. And so when we can think about exploring heterogeneity as a way to think about how generalizable our results are across the set of studies. If we're thinking about a set of studies that looks at the effectiveness of a treatment, we are exploring how much treatments might vary. And then we can maybe begin to think about for whom are they most effective and in what contexts are they most effective. And if we're looking at a meta-analysis that's instead looking at correlations between two constructs, we might still want to ask how variable are those effects, such as in the example with spatial skills and mathematics performance, that the strength of that correlation might be stronger for, say, boys than it is for girls. It might depend on how we're measuring spatial ability or math ability, and so forth. So again, in summary, we use meta-analysis in the context of a systematic review to synthesize results of quantitative studies. And meta-analysis can describe the average effect across studies, and we can use it to examine the amount of variation in those effects. Okay. And I think meta-analysis, like any systematic review method, can help us summarize what we know and what we don't yet know about a given research area. So I think that is the end of my slides, and I'd like to thank you for listening.
Thank you so much, Terri. We have about 40 people who have been listening to this throughout the past half hour. You might have some questions or some comments, because Terri has gone through a lot of interesting stuff and also quite difficult stuff to grasp too at times, but in a very easy way. So I hope that you might have something that you want to ask her about or comment on. And I see that we have someone in chat here, Alina. Alina has written here, thank you for such an informative and well-structured presentation. I was wondering, a common inclusion criterion in systematic reviews to strengthen the quality of the included studies is to only include studies that are peer-reviewed, but some argue that this leads to unrealistic overall effect sizes because of publication bias. That is, positive effect sizes are claimed to be overrepresented in peer-reviewed publications. What is your stance on this?
I think, yeah, thank you for that question. It is a very important question. So I think we have established pretty well in education and in psychological research and in medical research that in fact there is publication bias. Results that get published are going to tend to be bigger, splashier, more statistically significant. So what we say is that it's important to try to get a wide range of literature, including unpublished studies, because then we have a little bit more of a chance of getting a realistic, a realistic estimate of whatever we're interested in. Now, but I also want to say that that the second piece of that is that we sometimes equate peer review with quality of study, right? And I don't know how many of you, I think many of you probably do peer reviews. I do many peer reviews. I am not always a good peer reviewer. So I don't always think about peer review as equating or equal to quality. So what we need to also do in a meta-analysis is try to assess study quality. And the way I like to think about it is that we need to assess studies for quality or for their ability to address the question we're interested in. So if we're in the context of an intervention, we want to make sure our studies can support a causal inference. But if we're doing a different kind of meta-analysis, we have to think carefully about what would go into study quality, or the quality of a study to address the question of our systematic review. So I hope I answered your question. Thank you. Yes, I thought I saw a hand. Yeah, I thought I saw someone had a hand up. Yeah.
Was there a question?
Yes, hi, thank you very much. I was actually like typing my question in the
Sorry.
No, thank you very much, Terri, for the very interesting and very helpful presentation. I'm just wondering, because I always like to do some like meta-analysis kind of research, but I don't know how to do it. Can you please introduce some comprehensive kind of sources that, like explain step by step how we can do it, like using Stata or R?
Yeah. So, okay, that is a hard one. Okay. So there are, let me think, we are trying to develop some materials for people. I'll put in the chat and maybe a link to some materials that we have that are open that I've been developing with my research team. We have a couple of grants that do training, so I can share some of those with you. There are a couple of books that I think are really good as starters, which I don't know. Let's see, I don't know. Maybe you could put your email in the chat, and then I can send you a few things. I think the book by David Goff on Introduction to Systematic Reviews is really great. And then there are a couple of introductory books to meta-analysis. And then I always say, I do all of my analyses in R, and the program Metaphor by Wolfgang Weichtbauer, he has lovely resources. And I see in the chat, someone mentions the Cochrane resources, and those are always probably the first step, looking at the Cochrane handbook. But if you're in the social sciences, there's a few things that we do a little bit differently. But I'm happy to share a few resources with you. And again, I use R, and Wolfgang's resources are unbelievable. So Metaphor, the package Metaphor, he has lovely stuff there. And a lot of times he does a lot of free webinars as well.
Perfect, thanks a million. Thank you so much.
No problem.
I also put my email address in the
Okay, thank you. And I'll follow up and send you a few things.
Thank you so much. Thank you.
Okay, Leela too, yeah.
And we can also see that Terri will be joining us next spring for a PhD course on meta-analysis as well. most likely at least. So that you can always look out for that. And it will probably be open for researchers as well as PhD students. Lilla Magyari, your hand is up.
Yes, thank you. Thanks for the talk. And I just would like to, I just have a follow-up question on the first question, because I haven't seen really any selection of papers in meta-analysis based on quality. Is it right that I have the feeling that it doesn't happen that often, or can you give me just an objective, like an example how someone can say something objectively about this, like we left out this and this studies because I don't know, for some reasons, I don't know.
Yeah, I thank you. So we can think about sort of two approaches to this in meta-analysis. We can think about what my colleague Jeff Valentine says is our front-end approaches. So we might say, if we're interested in the effectiveness of an intervention, that we are only going to include randomized controlled trials. So we might say that. And then but we might also in that case want to make sure that our randomized controlled trials also are free of issues, such as a lot of attrition and so forth, okay? But we might be in the situation where the studies that, the question that we're asking and the studies that are available to us aren't randomized controlled trials, or there are no randomized controlled trials, because we might be, this just might be a situation where we can't do randomized controlled trials. So in that case, we might take what we call a back-end approach, where we may be more inclusive about the kinds of studies that we include, but then we are going to look at, the quality of those studies. And again, the quality depends on the question. So if we're interested in whether or not an intervention is effective, and we're going to include quasi-experimental studies, we may code each study for, was there a big baseline difference? How much was there differential attrition? That kind of thing. So, and then in the end, we need to use those codes that we've addressed to look at whether or not our effect sizes are related to that quality. We often see that there is a difference in the effect size we get from randomized controlled trials versus quasi-experimental studies. I don't always know, the direction is not always the way we think it is, but there usually is a difference. And so we do need to not just gather all the studies and gather all these codes about quality, we need to understand how effect size relates to study quality. And then we need to talk about it at the end of a meta-analysis about the credibility of all the evidence we have. If all the studies are sort of not that credible, then we need to say that we need to have that when we're talking about our results. Does that help, Lila?
Absolutely. So I feel that you try to find like objective criteria of statistical results or experimental design where you can either code it or make a selection based on those
yes,
issues.
Exactly. That's how we usually address it. Yeah.
Thank you.
Okay, thank you. Tamara has a question here. She was wondering which methods that you would recommend to assess publication bias in meta-analysis.
Oh boy.
Yeah.
Okay, so this is this is a very active area of research. I mean, super active. So what people have always done is done what we call a funnel plot. Basically trying, and so these funnel plots look at the relationship between effect size and sort of size of study. And that what happens when we do these funnel plots, however, is that if you don't have that many studies, then you can't see much. And also these funnel plots are sort of like Rorschach tests. you're going to see what you think you want to see in them. So there are a number of other statistical methods that people are beginning to use, and we think about it as a sensitivity. Like, how sensitive are our results to potential publication bias? So there is a test called Egger's test, which looks formally at the relationship between effect size and study size to see if there's a strong relationship there. There are also methods, statistical methods, to sort of explore sensitivity to selection effects. If we think that really we only have published studies there, and we're missing a bunch of unpublished studies, how much would that effect size change? So again, this is an incredibly active area of research right now. But what we think about them as is to explore the sensitivity of our results to potential publication bias. I know I didn't directly answer your question, but I can send along a few resources to you as well. You're on mute, Elaine.
I just said, Tamara says, thank you so much.
Okay.
So I can't see any hands or any questions here. There have been some questions about the recording and about the resources. And just to let you know that the recording, you can find it if you just Google Kunnskapssenter for utdanning, or the Knowledge Center for Education at the University of Stavanger. It will be posted here so that you can find it. Or you can get in touch with us and we can make sure that you get it. And that might be the best way to get the resources out as well, because I see there are quite a few that really would like to have the resources that you were talking about too, Terri. So you can just get in touch with me and we'll make sure that everyone gets what they would like to have, so that you can keep on doing your work. So, but Terri, just maybe round it off since I don't see any more questions. What would be your advice to someone who is going to start or thinking about doing a meta-analysis for the first time? What would you suggest that they do?
So I always talk about this as it being a team sport. That you need a group of people to do these with, because they're complex endeavors. So you definitely need someone who understands the literature, who understands the content of what you're doing, because there are lots of conceptual issues you have to grapple with when you're trying to think through a research question, and someone who understands sort of how these studies are typically conducted. So kind of going back to Leela's question, so you understand what what are the kinds of measures and designs that are used. And you also need other people around, because some of the stuff gets tedious. You also need a librarian too. The searching is so complicated. None of us can understand how to do all these searches without someone who really understands how to get at these issues in databases. So you need someone to help you with the search and someone to help you with the screening and so forth. I'd say that's what I would suggest. And you also need to think carefully about your question. There's lots of ways to make a question bigger and smaller, and the scope of that research question is really going to drive how many resources you need, because these do get resource intensive. They can be if they're big studies. So I don't know if does that get what you were thinking, Elaine?
I think it does. Yes, there's something about the complexity of it all as well, right? And it's not easy to just go ahead and do it on your own. So, okay, right. So thank you so much, everyone, for joining us for this little session. Thank you, Terri, for an insightful presentation, and also for joining us in this discussion afterwards. Thank you all. Have a nice day.
Thank you. Thank you.